Let's talk regression, a core concept in machine learning for predicting numbers, not categories. Instead of classifying emails as spam or not, regression predicts values like house prices or tomorrow's temperature. It's about finding relationships between variables to forecast a specific outcome. In this video, we'll break down 4 essential regression algorithms: linear regression, regularization, decision trees, and random forests. Let's dive in. First up, linear regression, the classic starting point. It finds the best fitting straight line through your data using the equation y equals sign mx plus b. The model tweaks the slope and intercept to minimize the squared errors between predictions and actual values. It's simple and interpretable for every unit increase in x, y changes by m, but it assumes a linear relationship, no strong correlation between features, and normally distributed errors. If your data is curved or has outliers, linear regression struggles. It's sensitive to extreme values and can't capture complex patterns, so it's a great baseline but not always the best fit for every problem. Know when to use it and when to move on. Next, let's see how to make it more robust. Regularization helps when your model overfits learning noise instead of real patterns. It adds a penalty to the loss function, discouraging large coefficients and keeping the model simple. Ridge regression shrinks all coefficients, while lasso can shrink some to 0, effectively removing unimportant features. Use ridge when most features matter. Use lasso when you want automatic feature selection. Elastic net combines both, balancing their strengths. Regularization keeps models general and prevents them from memorizing the training data. It's a simple add-on that makes a big difference. Now let's switch gears to a new approach. Decision trees predict by asking a series of questions, splitting data into groups at each step. Imagine a flowchart. Each node asks about a feature, and branches lead to more splits. The goal is to create groups where target values are as similar as possible. For regression, the prediction at a leaf is the average of the training values in that group. Trees are easy to visualize and interpret, but a single tree can overfit and be unstable. They're powerful, but need help to avoid overfitting. That's where random forests come in. Random forests build many decision trees, each trained on a random sample of the data and features. This randomness makes each tree different, reducing overfitting and increasing accuracy. For predictions, the forest averages the outputs of all its trees, smoothing out errors and biases. It's an ensemble approach, the wisdom of the crowd. Random forests are robust, accurate, and handle complex data well. They're less interpretable than a single tree, but much more reliable. If you want power and flexibility, random forests are a top choice. Now let's wrap up. 9. We covered 4 key regression tools: linear regression, regularization, decision trees, and random forests. Each has strengths and ideal use cases. No one-size-fits-all solution. Linear regression is simple and clear. Random forests are powerful and robust. The best way to learn? Try these models on real data and see what works. Build, tweak, and experiment. That's how you master regression. Thanks for watching.